morning. My name is Paul Moser, Superintendent of Steam Services here at Penn State University. And I'm here today to show you our operation of how we provide steam and electricity to campus, more than 200 buildings here at Penn State's University Park campus. I'll show you two facilities today. Our East Campus steam plant, which is located about a mile and a half to the east from here. Right now I'm standing at the corner of College and Burroughs Avenue. And behind me, you see the West Campus steam plant. And it's a coal-fired power plant built in 1929. And it's been serving the university since then, and it continues to, and I'll show you how we do it. So we're here at the West Campus steam plant, and from this view you can see the power plant behind me. And from here what I want to show you is how the coal, again it's a coal-fired power plant, how the coal gets into the plant and how we get the ashes that are created in a coal process out of the plant. So to my right is the entrance from Burroughs Avenue, and on a very cold winter day we'll take anywhere from 15 to 25 trucks a day of coal in through this gate, and the coal by truck, and the coal comes into the plant up this direction. And every truck that comes in we weigh on a scale, which is right here. We get a heavy weigh on the truck. Tells us how much the truck and the coal weighs. After we get that weight, the truck will back up underneath the coal pile and unload its coal. And we keep a storage basin here of coal. In the winter time, we'll have anywhere from 2,500 to 3,000 tons of coal on site. On the coldest winter day, on our coldest winter day ever, we probably used right around 400 tons of coal in one day. To the left here you can see a small pile, and that's where the coal is dropping on top of a hopper. And as the coal drops into that hopper, it's conveyed up to the roof inside the power plant, where we store about 900 tons of coal, and I'll show you that in a few moments. So we keep storage, and you'll also see on here we have some bins for some overflow of coal. If it's really rainy, we want to let the coal sit outside the roof and let it kind of dry off. But really the installation of the roof is primarily to keep the coal dry, so that on the wettest days of the year, when that coal, as you see it, this is a stoker fire coal, or a stoker style of coal, and it goes into the boilers just the way it comes off the truck. So the drier we can keep it, the much easier it is to handle, and it certainly burns a lot better when it's dry. Okay, so I'm underneath the coal pile roof right now, and I'm standing in front of what we call the grizzly, and all the grizzly is a hopper where we unload stoker coal from the trucks. And as you can see, this is a chunky stoker fired coal. It's not much different than the coal you would put on your charcoal grill at home. And just the way you see it here is the way that it goes into our furnaces. So, and as you can also see, it's nice and dry, and it's fairly chunky, and the chunkier it is, the easier it is to handle. Our system, our coal handling system is really uses gravity as much as we possibly can. So the drier this is, the easier it slides through our system. And you could imagine if these smaller bits got to be real wet, like coffee grounds, how hard that is to handle. The coal pile roof that we have over our head has really helped us a lot. We put it up in 2002, and since then we really have not had any problems with wet coal. So our real effort is to keep the coal as dry as possible, so that it gets into the furnace as easily as possible and can continue to burn and provide the campus with steam. So from here the coal is dropping down into this hopper, and then there's a conveying system, and you're seeing what is our secondary system here. There's another system I'll show you inside the plant. So we have a primary and a backup coal conveying system, which takes this and delivers it to a 900-ton bunker, and from that bunker we deliver coal to each one of the 4 coal-fired boilers. Okay, so I just want to share with you here the reason why we can have a coal-fired operation in downtown State College, which is where we're located. Behind me you see a large brown building. And that building is called our bag house. Inside the bag house are more than 2,000 Gore-Tex bags. They're about 8 inches in diameter. They're 23.5 feet long. And what we're doing is we're pulling the flue gases that leave the furnace with the fly ashes that are just naturally occurring from a coal combustion process. We pull those flue gases in through the cylinder, up through the cylinder of this bag. Again, more than 2,000 of them that are inside this building. And they go in dirty and they get pulled through the bag and they come out clean. The fans that are doing the work to pull that flue gas through are behind the brick building. And then the flue gases leave and they come out through the chimney. That's a 200-foot tall chimney. The platform's at about 175 feet. And it's in operation every day. We're a coal-fired operation. I've got 4 coal-fired boilers inside the power plant. And in order to get the flue gases out of the boilers and through our bag house, we use induced draft fans, or ID fans, and they're located behind me. And you can see here 3 fans that are operating to pull the gases out of the plant. And on a cold winter day, when our heat load is the highest, we need 2 of these fans to operate. And what's important that I want to share with you is that these are steam turbine driven fans. I'm going to show you several steam turbines in our operation. And what we're doing is creating steam at a high pressure, 240 PSI, pounds per square inch. And we deliver it to the turbines, and when they go through the turbines here at the fans, they're going to spin the fan and do some work. And then they leave the turbine at a lower pressure, and that lower pressure we call low pressure steam, and it goes to campus to a building just like Reber building here across the street and heats that building. So the value of plants, and not just West Campus plant, but any plant like this is a combined heat and power plant, which means that we're producing heat for the campus primarily, but at the same time, we're doing work with that steam to either spin a turbine, to operate a fan or a pump, or make electricity. And that combination of combined heat and power is very efficient. This power plant, which has 1960s vintage boilers, has been operating at more than 70% efficiency since it was built. So we're really proud of that. We want folks to understand that these types of plants that use the wasted heat in electric energy production are very efficient. And this is one example of that. We have a project on the way to modernize this plant, convert away from coal and go to 100% natural gas with fuel oil as a backup. And when we modernize this plant, our efficiency numbers will only improve from where we're at today. Okay, so now we're on the main firing aisle of the West Campus steam plant. And what you're looking at here down the aisle are the main boilers. There's 4 coal-fired boilers here. These are 3rd generation boilers. Again, the building was built in 1929. And in the 1960s, these boilers came in, and really for the life of the plant until the last couple of years, when the prices of fuel have changed, the coal-fired operation has been our primary operation. And we produce almost 95% of the steam came from the West Campus steam plant. Campus has grown from the West Campus steam plant location is really is why we've delivered so much steam from here. Coal is stored over our heads in a 900-ton bunker, and I'll walk you up there in a few minutes and show you how that works. But essentially, the coal is dropping by gravity onto a scale, and we weigh all the coal that goes into the boilers before it goes in, and it falls down through these distributors onto a stoker bed. And these boilers also have the capability of burning natural gas. We brought in natural gas into this plant in the 1960s, and we use it today to help us start up the boilers. It helps us shut down the boilers, and since the gas prices have come down, we're using it to steam and produce steam on the boilers a lot more than we ever did before. these are, again, 1960s vintage boilers, vibrating grate stokers. So the idea is that the coal is falling down onto a stoker bed, which is on a bit of an angle. You can see this angle here. The new coal drops down on the front of the boiler, and then every minute to a half, minute and a half, this boiler is going to shake, and you're going to see Gene Kurtz, he's our power plant supervisor. And I'm just going to open the doors here and just show you that about every minute, again, minute and a half, this stoker is going to shake. We call this a vibrating grate stoker, and there it goes. And each time it does that, that coal that's on the table shaking, if you could imagine just taking some sand on a board, and if you wanted to move it down the board, you'd shake it just a little bit. And that's what we're doing. So each time this shakes, the coal moves its way into the furnace, just a few inches at a time. And the higher the steam load, the more often it shakes. The bed of coal is about anywhere from 6 inches thick to 10 inches thick. The higher the steam load, our winter steam loads here on campus are 5 times our summer steam loads, and again, primarily we're a heating plant, so there's not a lot to heat in the summertime. Hot water, a few processes, not a lot. In the winter time, we're connected to more than 200 buildings on campus, and we provide 100% of the steam for heating. So I want to share with you how we get coal into our coal bunker in our primary system. And what you're watching here is the skip car with about 1,500 pounds of coal being carried on up to the top of the bunker. This is original plant equipment, came with the power plant in 1929. We really like this system. It's our primary system for its simplicity. And if you look down, you'll see a single drum. And on that drum are 4 different cables, and as that drum operates, it operates the entire coal handling system. We'll take you upstairs and show you how that gets its way into the bunker. But it's very simple, it's very reliable. We've kept up with this system, and it works for us every day. All right, so we're here on the top side of the coal handling system on top of the bunker, watching the what we call the old coal handling system. That's our tram car, and it's going to collect 1,500 pounds of coal. From the skip hoist, and then it's going to make its way back, and what you'll see down there is this tram car will roll over the frog, which will open the clamshell. And dump its coal into the bunker. And again, this is our old coal handling system, affectionately called the old system. Across the way is what we call the new coal handling system, installed in the 1970s. We call that the new system. But what we like about the old system is how reliable it is, how simple it is. It just operates back and forth. It'll do this all day long until this bunker until the bunker is full. And if you look down at each one of these, I have several of these across the bunker. These are our bindicators. And at the bottom of this bindicator is just a little paddle wheel. It's turning very slowly. In fact, this one's covered up. The one next to it is spinning slowly. And once the coal gets up and over the paddle wheel, it tells the control system that this section of the bunker is full. And then at that point, the control system will move the frog down a little bit further, and we'll just continue on filling it. And you'll notice here in this bunker, it's not all completely full. And the reason it's not all completely full is right today, we're here in September, it's early in the heating season, there's only one boiler operating on coal right now. And that's our boiler number 1, and this pile of coal is directly over top of boiler number 1. And we really like to use gravity as much as we can. We could pull coal from a different part of this bunker and drag it on over to boiler number 1, But if we don't have to, we won't do that. But as the heating season comes on, and that's really into November-ish, we'll start putting more coal boilers on, and this bunker will get more full. Okay, so we're on the roof of the West Campus Steam Plant. It's one of my favorite places, really anywhere on campus. It's a beautiful view here. Over my right shoulder, you're going to see the Tower of Old Main. And over my left shoulder, you're going to see Mount Nittany and the Happy Valley as you go to the east. And another point I want to make is down here to the south is the State College area. That's our downtown area. And all of our customers, all of our steam customers, are north of College Avenue, which are our buildings on campus. And so we're serving more than 200 buildings on campus with steam for heating, and you can see them this way. That's Reber Building across the street. This is Hammond Building connected to Sackett. In fact, if you were to watch this, if you see which way this truck is going down this alleyway, that's the original route to the power plant before it sat here on the corner. The first power plant here on campus sat at the corner of Hammond and Sackett Building. We're in the highest point inside the power plant on top of boiler number 1. Boiler number 1 is in service today. And again, our primary reason for being is to produce steam for heat. And this is the unit that's doing most of the work here at West Campus right now. And again, what we're doing is taking water, we're going to boil that water and make steam at a high pressure, 240 psi. The steam is leaving the boiler, and I'll show you where it's produced in just a moment. But it's leaving and it's coming through these two valves, up and through this pipe, and down to a header. And in that header is where all the steam goes in, and we draw it off and we send it to campus from there. And right down in here to my left is an example of what a safety valve looks like, and that's for protection of the boiler. In case the boiler should go high pressure, these safety valves would protect the boiler and protect everybody from a high pressure situation. I'm going to walk down here and just show you how the water gets into the boiler. So what we're doing is taking water from the water system. I'm a customer of the water system like anybody else would be. We treat the water, we soften it, we remove all of the minerals, we demineralize that water. So it's very pure, it's very high quality water. And it comes up into the boiler through the feed water system here and into the drum. We call this the steam drum. And inside that drum would be half filled with water, half filled with steam. One of the most important things we can do is make sure that that water level is correct, and I'll just walk you around and show you how we monitor it. If you look down along here, you're going to see a set of green lights and a set of red lights. So the green lights are telling you where the water is. The red lights are telling you where the steam is. And again, the number one thing that any of us do in producing steam in a boiler system is to make sure we have the correct water level. And we have 3 independent systems that do that. What you're looking at here is an iHigh system that's connected or being watched by a camera. And inside from this camera, we have a television screen down in the control room and are monitoring. This is one of 3. I'll show you the rest of them as we get downstairs. Okay, so we're in the main control room. We call this the boiler operator's room at the West Campus Steam Plant. And so far I've shown you some original plant equipment. That is the Skip Hoist 1929 vintage equipment. I've shown you some boilers that are from the 1960s. Here I want to show you really state-of-the-art control system, which is operating in our system here. And what it is an Emerson Delta V system, and I'm just going to walk you through a couple of the screens. And this is how we interface between our boiler operator to the operation itself. And if you start with the main overview screen of the West Campus Steam Plant, this is where we would start. And what it's doing is showing you the primary boilers 1, 2, 6, and 8 that do the lion's share of the work. But it also gives you an overview of the entire operation, including our East Campus steam plant. And if I move over to another screen, you'll see our East Campus steam plant. So again, East Campus is about a 1.5 miles from this location. And I'm showing you here the East Campus boilers that are, one of them is showing pressure, so it's online, available to do some production, but it's making no steam. And it's also showing you the new equipment that we put in there in 2010. And it's producing almost 30,000 kpph, 30,000 pounds per hour of steam at 220 psi, pounds per square inch gauge on the drum pressure. So this is our combustion turbine with heat recovery steam generator. We can monitor and operate this East Campus steam plant from the west, from this location here. There is staff at that location 24/7. Staffing wise, every shift we have 6 teams of 3 that staff us 24/7. So we're here every day. We have a boiler operator who's responsible for this room, and he reports to a lead operator who's responsible for the entire shift. And the operator at East also reports to that lead operator, and they are in charge of the shift. They make all the decisions operationally for us, and we rotate these. We're running 8-hour shifts Monday, Tuesday, Thursday, Friday, and we run 12-hour shifts on the weekends and Wednesdays. And this screen here just tells us what the steam trends are for the daily trends. And across the bottom you can see what time of day it is, and here you can see up on the left you can see just how much steam flow we made. And this green line I'm going to highlight in just a moment is our steam flow leaving the West Campus steam plant. And what you can see here is right around 6 in the morning that steam flow is going to increase. Here we were producing about 60,000 pounds an hour, and it worked its way up to about 80,000 pounds an hour. And so we picked up almost 30% of our load in the morning from West, and that's campus waking up. Typically today's a Tuesday, so that's our students waking up. That's the heating system starting to heat up buildings that we've had set back over the evening. That's us making hot water for showers. That's us getting the kitchens ready to do some cooking. So we're almost always seeing an increase in steam load in the morning, and then it trails off over the day. Okay, and so again, West Campus steam plant is the primary plant. The campus evolved around West, and I'd like to tell folks the campus effectively tilts to the west. So all the steam that goes and hits a building to produce steam comes back to us as water, and we call that condensate after it's given up its heat to the buildings. And we collect that water in a condensate system, and what you're seeing here are those tanks that are collecting the water. This is condensate. We will recycle that. That'll come back here to the West Campus steam plant, and we'll put it back into the system, and we'll boil it again. We get about 75% of the water that, 75% of the steam that went out to campus comes back as water. And it all comes back here to West Campus steam plant. Again, the West Campus was built long before East Campus was. East Campus didn't come to us until 1972, and really had no infrastructure to handle the recycling of condensate. So it all comes here to West. And as I said, up on top of boiler number 1, we have 3 different ways of measuring water level. It's our number 1 thing that we do as operations, is to make sure that we have proper water level in the drums. Here's the camera I showed you. Here's the screen that's showing you boiler 1. Those are the same green lights we were just up there looking at there, and that gives the operator a visual indication of water level. We can also measure water level in another independent way, looking directly at the boiler. The blue is water, the white is steam. This is a screen of just boiler 1 operation, showing you what the pressure in the drum is, what its steam flow is, how much fuel and air we're putting in, and the fact that we have a coal-fired boiler, coal fire in there. And you can also see boiler number 8 is operating too, the same information, and this indication shows that it's operating on natural gas right now. So this is our second means of identifying what the water level is, and we actually have a third independent means up here. The red light when it's on indicates where the water is, and where the lights are off indicates where the steam is. So 3 independent ways of determining water level. Behind us is the coal and ash handling controls, and as we transfer over from coal to natural gas in this project's going to take us about 3 years to complete, maybe 2.5 to 3 years to complete. And as we do that, you'll see all of our coal and ash handling equipment go away. We're also monitoring how much electricity that we produce here on campus. Our modernization of the East Campus gave us the ability to produce almost 8 megawatts of electricity in the winter time. And what we're doing with this machine is to determine what it costs us to produce electricity versus what it costs to buy it. So, you know, right now we have a direction from the turbine dispatch to be at full output. That means that it's a cost savings for us to operate. And but when the weather conditions change and the real-time market for electricity changes, we might find that it's more economical for us to buy more electricity than we produce. And this turbine dispatch would tell us that. On the hottest summer days that we had this summer, with our combustion turbine with heat recovery, when we're making 8 megawatts of power, we're saving the university about $2,000 an hour in being able to operate our own electric generation system. Okay, I want to share with you our maintenance program here. For these coal-fired boilers, each one of the boilers gets a 6-week outage through the summer. We start in April and we finish in November, and this is what you're seeing here. It's our last boiler that we're completing here. It'll be done the end of this month, maybe early October. This is boiler 2. And again, what you're seeing is a complete maintenance. We take the boiler apart, we clean and fix what needs to be fixed. It gets inspected by the boiler inspector to make sure everything's working properly, and then we put it back in service so that it can operate through the winter continuously without failure. It's important for us to get through the winters. On a very cold winter day, both the West Campus and the East Campus steam plants need to operate in order to meet the campus demand. So not all the boilers will be at full load, but the boilers will all be operating or operable in case we need them for that cold winter day. Neither plant can supply 100% of campus in the winter time. We just don't have that ability to move the steam from one end of campus all the way to the other end of campus. So what you're seeing here is the end of that maintenance program. We have 8 full-time maintenance folks, mechanics, instrumentation and meter techs, and electricians that are doing the maintenance, plus a group of folks that are doing the lion's share of the bulk maintenance on the boilers, another 6 of those folks. We call them our our coal and ash folks. So when they're not pulling ashes or putting coal into the plant, they're doing maintenance for us, and that's what you see going on behind me. Okay, so Mr. Ripka is our boiler operator. He's just going to share with you what a coal-fired boiler looks like. And these are this is the end of the coal combustion. Those are we would call those bottom ashes. And you're seeing the tubes line the ceiling, and in those tubes are where the steaming is occurring for the boiling process. Those ashes will fall off. They'll be completely burned out, and they'll fall off the back end of this furnace, and we'll collect those ashes. You can see it shaking right now. You can see how it moves just an inch or 2, maybe 3 on each time it shakes. And we'll pull all those ashes out. We'll collect them, and they go off to a landfill. So while we do in our peak year about 70,000 tons of coal in our peak year, at that same time we do about 5,000 to 6,000 tons of bottom ash. Okay, last stop for the day here at the West Campus Steam Plant. You're on the turbine island where we produce electricity for campus. Unit 2 here produces about 2.5 megawatts. It's built in the 1930s. And Unit 3, about 3.5 megawatts, built in the 1940s. And what we're doing here is taking high pressure steam at 240 PSI into the turbine. In fact, number 2 is operating right now, but it goes into the turbine and it does some work, spins the turbine, connected to an electric generator, makes electricity. So our peak electric demand on a hot summer day is about 50 megawatts, and I'm making only about a megawatt here. So a very small amount, but I'm also making 100% though of the emergency power necessary to light those small emergency lights in each one of the buildings on campus. So if we were to have a total loss of power here on campus, the operation of these units would light those lights, and it would also keep us running here at the West Campus Steam Plant. So we can go completely off the grid if need be in a total loss of power. We'll continue to make steam on a day like that. So before we move on to East Campus Steam Plant, I just want to share with you a project that is underway now to convert away from coal and convert this plant over to natural gas. The reason for that project is to come into compliance with new air quality standards that came into place in 2013. So in doing that, all of our coal operations will be converted over, and basically that's everything you can see going this direction from the power plant. Is coal and ash handling goes away, and we will, in 3 years, you won't see any of this equipment, and we'll be 100% on natural gas. So while I showed you some equipment in there that's all operating reliable, but some of it's 1960s vintage, we've got some 1930s vintage electric turbine generators. Those are all in the process of upgrading, and this will be a modernized power plant in 2016 is our compliance date. Okay, so now we're at the East Campus Steam Plant. Behind me you see the power plant. You see that we're actually taking a delivery of low sulfur diesel fuel now. It's our backup fuel. East Campus Steam Plant, its primary fuel is natural gas. It was built in 1972, and the purpose of the plant when it was built was to be a peaking plant. That is to only be used on those very cold days when we simply could not move the steam from the West Campus Steam Plant to this side of campus. And as I've said before, that the campus grew really from the west to the east. So as buildings came on through the years, as those buildings came on, the ability to get the steam from that side of campus to this side of campus really got impossible. So in the 1970s, this building was built, 2 packaged natural gas fired boilers, and until we added power to this in 2010, I'll show you that project, but up until 2010, really this plant only produced about 5% of the steam a year. There's no cogeneration capabilities here, makes no low pressure steam, none of the condensate comes back to East Campus Steam Plant really. So we really only used it on those cold winter days when we had to have that steam from this side of campus. Since we've done a project here, again I'll show you that project, since we've done that, now we're producing about 30% of the steam a year comes from the East Plant using combined heat and power. That is a combustion turbine with a heat recovery steam generator. Modern efficient equipment makes 8 megawatts of electricity at the same time. So you're going to find that this plant, we're starting to upgrade this with the ability to bring condensate back to this location. We're adding the infrastructure to do that. And we're also adding the infrastructure to get additional steam out of this steam plant so that it can be more useful to us in the wintertime, and also in the really all seasons of the year. So what's happening here, and I'm standing right here and showing you this little green candy cane, the steam is coming out of the plant in pipes, and those pipes are underground. And they hit a manhole right here. We call this manhole 262. That's just its name. And from this location, we have steam lines that go north up on Porter Road, and you can look north and see Beaver Stadium. We're across the street from the outdoor track. We share a property line with the Center for Sustainability. We have one line that goes north, and we have another line that kind of heads due to the west over here towards campus, that direction, and that'll pick up. And so we have two feeds to campus from this location. Okay, so just another view of the East Campus steam plant, and you can see here the old original plant. That's the 1972 building here to the left, and then coming off the back is the building that we put in service in 2010, where we added a combustion turbine with heat recovery steam generator. I'll show you that in a moment. You also see a good bit of construction equipment out front. So we're investing in the East Campus steam plant. We've again added new high efficient equipment that we want to operate and serve the campus and start getting the condensate back to this location. We also went in and refurbished the two original boilers, again 1972 package boilers. So they've gone through a major overhaul, which will make them 100% reliable for many years to come. So that's what you're seeing here. This project will be done really probably the end of this month or going into October, and we'll be ready for the heating season, and you'll see all of this construction equipment start to go away. Our next stop will be inside the plant. I'll walk you through the old plant, and then we'll walk in towards the new plant. Okay, inside the East Campus steam plant, this is the original part of the plant, the 1972 building. And off here to my right are boilers number 1 and boiler number 2. These are packaged boilers. They operate on natural gas with fuel oil as a backup. And we're just completing the refurbishment of both these boilers, and what we're doing here today is tuning the boilers and starting them up and getting them ready for the heating season. I'll go ahead and walk you back through here into the addition. As East Campus steam plant develops and we operate it more, we really want to get that condensate as after the steam goes to campus and gives up its heat, comes back as condensate. As I said, really little to none comes back to East Plant until we do a project to get that. And that's what you're seeing in this room here is a softening system to take that water and clean it up again, get rid of any contaminated, or that is hard water that might have gotten into the system with these polishers. So what we're going to do in this room is we're preparing. This project is just wrapping up. Beneath the floor here is a storage tank where we can store condensate and recycle it back into the East Campus steam plant. This is all brand new equipment, has not gone in service yet, and it's part of our efforts to make East more of a lead plant than it ever was before. I'm going to walk you right in here to the addition and show you where the combustion turbine with heat recovery steam generator is. Okay, so now you're in the addition to the East Campus, and you can see that here's the original brick wall of the back of the building, and we built on this way, and you're looking at the heat recovery steam generator, HRSG, and it's a boiler. There's a steam drum at the top. That's the circular shape there. That's where the steam is produced. And the flue gases come through this boiler from the combustion turbine, which I'll show you in just a moment. This boiler is capable of producing 117,000 pounds per hour of steam. And on a cold winter day, that's about a third of the campus's total steam needs can come from this unit. And it'll be producing that at more than 80% efficiency. It's very efficient. And that means when it's operating at 80%, it's much more efficient than any kind of electricity we can buy off the grid. Your average electrical grid, that is a utility power system, produces electricity at about 33%. And our system here is operating out at more than 80%. I'll come down, we'll walk down the steps, and I'll show you what the combustion turbine looks like. Okay, so I'm standing in front of the combustion turbine, and in a moment I'll open these doors for you and show you. But what it's going to get real loud, and I'll put my hearing protection on, but what you're going to see is a jet engine technology, and this jet engine is connected to an electric generator. And when the jet engine spins, it's connected to the generator and produces 8 megawatts of power, 8,000 kilowatts. Again, our hot summer day is about 50 megawatts on campus. The exhaust from the jet engine leaves the engine and goes through this ductwork at about 900 degrees and goes through this boiler. And that temperature and flue gases are enough to produce, when it's just simply firing with the engine, 30,000 pounds per hour of steam. And you saw that on the screens at West Plant. We can also add some what we call duct firing, and this is the duct right here. We can add some additional firing capacity here and take that capacity from 30,000 pounds an hour all the way up to 117,000 pounds per hour. Again, very efficient use of this engine. So what I'm going to do is go ahead and put my earplugs on, and I'm going to have Gene and Mike. Mike is one of our lead operators. They're going to go ahead and open up the doors and show you what this technology looks like. The combustion turbine, and I just want to share with you some of the important features of this unit that we put in. In addition to it operating very efficiently, we put it in and we developed this project in 2007-ish. It went online in 2010, and it provides us not only additional capacity, but the electricity that it produces, that 8 megawatts of power, goes a long way to the university being able to provide enough power for campus should we have a total loss of power. That is a place to provide safe refuge in case we didn't have incoming electricity. We can find a place to put not only our students, but our first responders and other folks, possibly even from the community, in a place where I can provide steam, electricity to keep lights on and keep buildings warm. We can do that now that we have machines like this combustion turbine. Again, it produces about 8 megawatts. We think we need about 12 to do that, 12 megawatts, and we've got other sources of electricity that'll do that. So a couple important features that this machine provides for us. Okay, so we're inside the control room here at the East Campus Steam Plant, and you can see here controls look identical, because they are, to the West Campus Steam Plant. Here's your overview of East Campus. We saw that same screen at West. Here's our combustion turbine with heat recovery steam generator making 7,000 kilowatts of power, or 7 megawatts of power. And at that time, we're making 30,000 pounds an hour of steam. So here at East, like at West, we can control the other plant from this location. We don't do that. We do have that capability to do that if we needed to. And your overview of the West Campus Steam Plant is here. So we have a full-time operator here today, and his job is to see to the operations of the East Campus Steam Plant. But he works in concert with the operator at West Campus Steam Plant through our radio. So we're directly connected. Anytime he needs to communicate with the rest of his team, he has connection to them through our radios. Okay, our final stop here inside the East Campus Steam Plant is in the water treatment room. And so we're a customer of the water system here in Happy Valley. Almost all of our water is groundwater, comes from the ground. It's fairly hard. It's got a good bit of calcium magnesium hardness in that water. So what we're doing, this plant is nearly 100% makeup plant. That means that all the water that goes to producing steam is coming from this water process system. So the blue tanks over here are your softeners, so we're softening all the water to 0 parts per million of hardness. And we're also demineralizing that, or taking the normal that's created dissolved minerals in water, and we're filtering that out with these reverse osmosis system. So the water that goes into the boilers is very, very pure, and what that does for us is really minimize any kind of scale that might build up on the boilers, and it also minimizes the amount of water we need to flush out of the boilers to get rid of those minerals that otherwise we would have to do if we didn't have these units. So 100% of our water comes through here, and I'm standing on top of a storage tank that holds more than 40,000 gallons of water. As our system develops, as we bring condensate and more condensate back to the East plant, we'll need this water less. And so then we'll be recycling more from the East Campus steam plant. Thank you everyone for joining me today on a tour of the East Campus and West Campus steam plants at Penn State. Just want to leave you with some final words. You didn't see a lot of folks walking around this plant today, and I want you to know that we have more than 40 folks that work in steam services. We have technicians, we have supervisors that are making this operation run. We're supported by the physical plant engineers that really provide a lot of expertise for how we operate this system. And we have a real simple mission, and that is to provide steam and utilities to campus safely, reliably, and efficiently every day. We take that very seriously, we take that to heart, and again, I want to thank you for joining us today.